Hey everybody, this is Chase with Trick Tools, and today we wanted to do a video giving you 5 things we think you need to know before purchasing a tube bender or before you start bending. This is a list that we compiled based off of frequently asked questions on the website, questions that our sales guys get, things we hear at trade shows, things like that. Sometimes we hear that it's a daunting task, or it may seem a little bit intimidating to get into, or that it requires a lot of talent to get a certain bend. And so what we wanted to do is just give you some of the common terminology around tube bending, hopefully clear up some misconceptions out there, and hopefully give you a good foundation to get started with bending. So number one is understanding the difference between tubing and pipe. And a lot of people use those two terms interchangeably when in reality they are two very different things. Tubing is commonly used for structural application like roll cages or chassis fabrication, whereas pipe is commonly used to flow liquid or gases through them. So in front of me here, I have an 1.5 inch tube and an 1.5 inch pipe. As you can see, they're very different as far as the OD or the outside diameter goes. And the reason for this is because of the way that they're measured. So tubing, we measure on the OD or outside diameter. So if we put our calipers around, it'll read 1.5 inches on the OD. And another important measurement to note is the wall thickness, or how thick is the material that you're bending. So if we pinch the material in the calipers, we will get 0.63. So this is 1.5 inches, 0.63 wall tubing. Pipe is measured on the nominal diameter. So our 1.5 inch pipe, if we measured it on the outside, will measure 1.9. Another important thing to note with pipe is that it uses the term schedule as wall thickness. If you have schedule 40 pipe, it's going to be thicker than schedule 10, and schedule 80 is going to be thicker than schedule 40. So schedule is your designation to how thick the wall of your pipe is going to be. The one thing that remains constant here is that the OD is going to stay the same. With an 1.5 inch pipe, you're going to have a 1.9 outside diameter, and the schedule is going to determine your inside diameter. So number 2 is going to be Centerline Radius, often abbreviated as CLR. So in front of me here, I've got 2 bends, and I've drawn a Sharpie line on one to better illustrate the centerline radius. So what's important to note here is that centerline radius is measuring to the center of the tube. So I think one common mistake is people measuring the outsides of the tube or the inside of the tube. The centerline radius is measuring through the center or dead center of the tube. So there are several ways to measure this. One would be is if you have a die, so like this die I have in front of me here, I have an 1.5 inch tubing die. We can measure from the center of the pivot pin to the outside of the die, because the outside of the die in this case covers the center of the tube. And that is a 6-inch centerline radius. Another way to do it would be in a 180 bend like this. We could measure from the center of the tube to the other center in a straight line. We would get 6 inches there. Since that's the diameter, we would divide that by 2. So that's a 3-inch centerline radius. If you don't have a 180-degree bend, and say you have a 90-degree bend, if you measure from the start to the end of the bend and draw a straight line from those tangent points to a point in the middle of the bend, that would be your centerline radius. Centerline radius is important because if you're working in a roll cage or something like that, there are minimums and maximums that you can have. It's also going to dictate how much room you're taking up with the bend. Another important note with centerline radius is that most dies are going to have a minimum wall thickness. And sometimes this is contradictory to what people think, because you're going to think the thinner the tube, the easier it is going to be to bend. Well, it may be the case as far as the capacity of the machine goes and how much force is required to actually bend the tube. But what really happens with thin wall tubing is that you're going to get wrinkling on the inside or flattening out on the outside of the bend the tighter that the centerline radius is. When it's a more broad bend, you can bend thinner wall tubing because the material doesn't have to do as much shrinking and it doesn't go through as much distortion. The tighter the centerline radius goes, the more that tube has to stretch in order to make the bend. So when you have a thinner wall tubing, it's more prone to that. Just because there's less material there to be manipulated. So centerline radius is a great way to segue into my next point, which is number 3, Mandrel bending. There are a lot of misconceptions out there around what a mandrel tube bender is, what it looks like, what tubes look like that come out of a mandrel bender. And so we wanted to clear that up for you here today. What I showed you earlier when we were talking about Centerline Radius was 2 mandrel bent tubes. These are very thin wall and very tight radius bends. And the only way that's achieved is with a mandrel. And so what a mandrel tube bender is it has a mandrel that goes inside of the tube and supports the inside from collapsing, wrinkling on the inside, or the outside of the tube from flattening out. Mandrels can look a lot of different ways, but they are specific to each size of tube and even the ID of the tube. So that's why mandrel tube bending has such a high entry point for that market. We're looking at, $50,000, $60,000, $70,000 to get into mandrel tube bending. But obviously the result is you get very, very high quality bends with little to no deformation. Typically these machines are bending tubes for high performance exhaust, a lot of different applications out there where you just need a really tight bend to fit into a really small space. Most commonly, you buy U-bends if you're building headers or something like that. But if high production is something that you're looking at, a mandrel bender is a great way to get those super tight radiuses, specifically on really thin wall tubing. So number 4 is going to be degree of bend, how that's different from Centerline Radius and Springback. So when we talk about the degree of bend, what we're really referring to is how much the tube is wrapping around the forming die. These are all 90-degree bends, and they're all different centerline radiuses. When we're talking about the degree of the bend, we're talking about the angle of the actual bend. So if we wanted to illustrate that, we could use an angle finder. You can see that it's 90 degrees there. That is not dependent on the centerline radius. The next thing with degree of bend is springback. And springback is another very common term used with tube bending. And really what it is when you bend a tube, it's the material trying to return to its original state. Say hypothetically we wanted to achieve a 90-degree bend, and we bend the tube around the forming die to where the pointer reads 90 degrees. We may pull the tube out of the die and see that it's maybe 85 degrees or just short, or it had maybe sprung open a little bit. And that's really where the term springback comes from. So when we talk about calculating for springback, what we're really trying to do is bend just past the point where we need to go. So if we're trying to achieve a 90-degree bend, we may want to bend it to 95 degrees. And there's no exact way to calculate how much springback you're going to need. It usually requires a test piece, and the reason for that is because there's a big difference in wall thickness and how much it's going to spring back. There's material differences. So for example, chromoly is going to spring back more than a normal mild steel tube, and different wall thicknesses are going to spring back more than other, even if it's the same alloy or type of material. So hopefully that clears up a little bit about the differences between degree of bend, centerline radius, and springback. So number 5, we're going to talk about tube bending dies. And one of the big things when it comes time to purchase a tube bender is making sure that there are dies available for, whatever the project is that you're tackling, or future projects for that matter. Tube bending dies are usually very specific to the tube bender itself. If the manufacturer isn't making certain centerline radiuses or things like that, the dies aren't going to be interchangeable from tube bender to tube bender or manufacturer to manufacturer. So when you purchase a tube bending die, you actually get 2 pieces, and that's why we call it a die set. So you get your forming die, which is the part that forms the tube, and is specific to the centerline radius, and you get your counter die. It's important to know this because the counter die is also going to be specific to the OD of your tube, just like the forming die. Another important thing with dies is the degree of bend that they're capable of. If your project requires 180-degree bends, to make sure that you are buying dies that are capable of that, because there are dies out there that are just 90-degree bend dies. Make sure you're looking out for the max degree of bend that they can achieve. Another thing with dies that we've kind of touched on is most dies are going to have a minimum wall thickness that you can bend on them. And like we touched on, it was about the tube wrinkling on the inside or compromising the integrity of the tube when you're making a bend. When we look at tube bending dies, really what we're wanting to pay attention to is the max degree of bend that they can achieve and what is the minimum wall thickness that you're going to achieve with that radius of die. Well, there are the 5 things we think you need to know before purchasing a tube bender or before you start bending. Like I had mentioned earlier, we have a great technical resources tab on Trick-Tools.com that'll go over a lot of what we talked about today in this video. So if you have any more questions past that, feel free to give our guys a call or shoot them an email. We'd love to get you set up and help you out. Hopefully you found this video insightful, and thank you for watching.